So I got a phone call yesterday about the Killer Instinct machine at the business. For those of you who don't know, I actually am co-owner and operator of an arcade here in Wichita, Kansas called The Arcade. And I am responsible for the maintenance and the repair of all the arcade games and pinball machines. And my partner keeps the business running. So he runs the business, I run the repair, and we work 50-50 that way. But anyway, so I got a call about the Killer Instinct machine was dead, completely dead. I said, okay. So I asked the person that was working for us, who was telling me about the problem. Okay, is the marquee on? Can you hear the game running? He said, nope, it's totally dead. And I got to the business today, and sure enough, it was completely dead. The main 3 amp cabinet fuse was blown. So I replaced it. And when I turned the machine on, everything came back on. The marquee came on, the power supply, the game, you could hear it running, but the monitor was playing blind. I checked the fuse and it was blown on the chassis here. So I put a new fuse in, turned the machine on, boom, fuse blew immediately. So something went wrong in the machine. I can't say if it was the machine's fault or the chassis' fault, but with the monitor disconnected from the machine, it works perfectly. Marquee, power supply, the game plays, you can hear it running, you can actually play it. The machine is perfectly fine the way that it is, but there's something wrong with the chassis. As soon as I put a new fuse in, it goes kaboom. So we have a K7000 here that's blowing the fuse. I don't know why the main cabinet fuse blew. Maybe there was something here that shorted that took out that fuse before this one blew. I can't say. Because I checked this fuse before replacing the 3 amp fuse and it wasn't blown. So as soon as I replaced the 3 amp cabinet fuse and turned this back on, that's when this blew. So I replaced it and it blew again. So I think something happened in the monitor that shorted out the 3 amp fuse on the main cabinet 3 amp fuse, and then when I replaced it, it worked, and it took this one out. Since this is 2 amp versus 3 amp, I can't say the series of circumstances, I can't speak for that, but it's definitely the chassis that's causing the problem. So I put the new fuse in and it blew immediately, and you can see that it's just smoked. Kaboom. So we're going to have to figure out what's causing the fuse to blow. It can really only be a few limited amount of things. Let me get my pointer here. With the fuse being exploded like this, you can see how charred it is. With the fuse being exploded, it's either going to be something going on with the diodes in the DC rectifier circuit. It's going to be the voltage regulator. It's going to be C38 or C36. C36, C38, the voltage regulator, or these diodes. Now the HOT itself usually doesn't cause the fuse to blow. It can. It's not unheard of, but usually the HOT will just short out or open up. And it may not necessarily take out the fuse, because I've seen it before where the HOT was shorted but the fuse wasn't blown, because the HOT would short and take out something else. But the HOT is, I guess you could say, it could be a cause of the fuse, but it's more likely it's one of these other things, the diodes, C36, C38, or the voltage regulator. But I mean, it could be, for completeness sake, the HOT as well. So we'll check those 5 areas, diodes, 36, 38, voltage regulator, and HOT. So it's almost guaranteed to be one of those 5 things, or more. This has been rebuilt. I rebuilt this before sticking it in the Killer Instinct. It's got all new caps and a new flyback. But you can see that it's been about 3.5 years since we've opened, and in those 3.5 years, it's gotten pretty dusty, pretty dirty. It's been, it's been on. We're not open we're open 4 days a week for about 12 hours average. So it's been running all that time in 3.5 years like that. And it's been good, like most monitors, they don't last forever. But it has been rebuilt previously. And when I built it, it did not have this burned area. So this has generated a lot of heat in the last 3.5 years, but that's very typical of a K7000. It's an area that we're going to have to reflow and inspect heavily. I can already tell there's a heavily oxidized pad right here. This guy right here. This whole area here has been nice and hot. This right here is very suspect. That should be shiny, and it's completely gray and dull. This here, this got very hot, and I even put a solder blob there in the past to make sure it stays a good connection even when it gets hot. This was from a previous cap kit. before I started. This was before I developed the technique of using the fiberglass pen to kind of scratch off the solder mask and just solder directly to the solder mask or directly to the trace. But this works. So we're going to have to go through and redo all of this stuff here. And then also we'll have to obviously check our possible bad parts. So we'll start with our diodes. And okay. Again, negative on the side with the stripe, positive on the side without the stripe. Diode checker setting on the meter, and we'll check D19. That one's good. D20, D21, D22, D24, and D23. Well, those are all good. Let's test our HOT, which again is this guy right there. And it's going to be this triangle here by with the hole 1, 2, 3 right here. Negative. Oh, HOT is gone. There we go. HOT is shorted. So that's going to have to get replaced. That's one down. C36, which is our critical safety cap, that guy right there. So again, that's it's these 4 pads here. 1, 2, 3, 4. You're going to want to check 1, 2, 3, 4. So we'll go negative on this side and positive across, and it reads shorted, and it's going to read shorted now that I think about it, because the HOT is shorted. So we're not going to be able to see if the critical safety cap is good until we replace our HOT, because if the HOT is shorted, the critical safety cap will read shorted. So now you're in a conundrum here of, is it C69 that's shorted that's causing the HOT to read shorted, or is it the HOT that's shorted that's causing 69 to read shorted? You'll have to take one of them out of the circuit and find out. But most likely it's HOT. And of course it could be the critical safety cap C69 as well. So we'll get to that when we get to there. Let's test C38, which is going to be this pad and this pad. C38 is not shorted. It should be like 1.5 mega ohm or something. Well, it's dissipated because I've touched it already, but 1.8K. Either way, it's not shorted. That's all we're worried about. So C38 is shorted. Our voltage regulator, this kind here, STR3130, the fat kind with the 2 on the side as opposed to the single one in the middle. On this one you test pins 1 and 4, but our blue and red wires to our B+ resistor go to pins 1 and 4, so it's easier to just test our B+ resistor for the 200 and some odd, or is it 180? I think it's 180 on the 25 inch and it's 220 on the 19. So we'll go to the ohms here and we'll test. This should be around 180. And it's 4 ohms. So our voltage regulator appears to be shorted as well. Nice. So that's an easy way you can test your voltage regulator. It's 4.2 ohms. So our voltage regulator is definitely shot as well. Interesting. All right. Well, I guess this kind of completely exploded on me. Very interesting. Well, let's take out the HOT from the circuit and see if C69 still reads good, and we'll test our HOT out of circuit. Let me turn my desoldering iron on, or desoldering gun I should say. I'll turn my fan on too. This thing's failing on me. There it goes. You can hear that? Listen. That's the fan inside of my desoldering station. If I give it a nice little whack, it shuts up and starts working. So what do you want for $300? Okay, it's heating up. So in the meantime, I guess we can get the screw out. right. Set that aside. And just like that, it's out, so to speak. It should come right out. There you go. About 15 seconds, it's out. The desoldering equipment is pretty good when you know what to do or know how to use it. All right, so let's test it out of circuit. Let's put it on something that's not conductive because my work table is conductive. So we'll go to the base. Now if this reads good, let's go out here. If this reads good, one leg will read 0.5 and the other leg will read open. Of course, if it's not, it'll read shorted. It is shorted. So in the garbage that goes. Kaput. Now let's test our, let's get this out of the way here so we don't lose it. Now let's test our C69 again. And I'll bet you it's fine. We're not going to read a diode because the HOT is out, I don't believe, but let's see here. Again, it's these 4 pads, 1, 2, 3, 4. Now there's nothing in this one, but I still read it the same way. Yep, no longer shorted. Yep, so there's our diode. Obviously it reads through something else. I was thinking it read through the HOT, but you read diagonal like this. Negatives on this end, positive on that end, the caddy corner, you'll read, there's your diode. So, yeah, it's not C69, it was HOT. So now we got to change our voltage regulator as well. We can double check it again. It's pins 1 and 4. I think pin 1 is positive, 4 is negative. Let's see here. Yep, shorted. So let's take that bad boy out as well. Now let's see if I can get this out. Look at that, right out. I love this desoldering stuff, it's really good. Alright, so now we can test our B plus resistor again. Now it should be 180 ohms. there you go, 177. So we have a bad HOT and a bad voltage regulator. There's the voltage regulator. In the garbage it goes. Okay, I think that was everything that everything that would cause the fuse to blow. We just tested. Like I say, HOT, diodes in the power or the rectifier circuit, C38, C36, and the voltage regulator. We found a bad HOT and a bad voltage regulator. So, yep, we'll change those out, and then we'll replace the fuse, and I'll go through and do all this reflow, I guess. What I'll do is, a lot of people don't understand what really reflow means. They think it just means add new solder, but it means remove the original solder, clean up the pad if it needs to be, and then put new solder on. It doesn't just mean flow new solder by the definition of what it is. So what I'm going to do here is there's not a lot of surface area to the tip of this desoldering gun, so I use the regular soldering iron to heat up the pad and the solder, and I just suck it up real quick with this. It's a much easier and quicker process. So what we'll do here is, it looks like that pad opened up or broke. Piece of junk. There you go. It looks like this is free of the trace. No, it's still good. Well, it looks like garbage though, so we're gonna clean this up here. What the hell's going on with that? Okay. Well, I'm not happy with, not super happy the way that looks, but I don't have my fiberglass pen. I don't have my fiberglass pen with me, but that's still a million times better. Usually I like to take the component out of the pad and clean the pad up with my fiberglass pen, but I mentioned before a couple of videos back how the ones I have are junk and I haven't been able to find a correct one yet. But that's a lot better, so I'll say we'll call that okay for now. Let's do this one, because these pads get oxidized, and over time from the heat they won't hold a good connection, so it's good to get the oxidation off of them. That's better. That looks like complete ass there, but you know what? Let's clean that up a bit. That's a bit better. Those pads must be gone That's why this jumper's here. That'll have to be good enough for now. I don't like it, but it'll be good enough for now. Anything else I should do while I'm here? D18 looks kind of suspect here. I guess, you know, now that I think about it, D18 could cause the fuse to blow, but D18 shouldn't cause your voltage regulator to blow. It'll kill your HOT, but it won't kill the voltage regulator, not in a normal circumstance. And everything else seems okay from what I see here. Usual suspects. Okay. All right. Well, let's grab a new HOT and a new voltage regulator and a new fuse and see what we get. Okay. Soundboard stuff, G07 stuff, HOTs for G07s. Here, jackpot. All right. Okay, that's the counterfeit one. Counterfeit. Good, good, good. Counterfeit, counterfeit. Let's see, that was a 130, right? Okay, I got one 130. And let's test to make sure it's good. Pins 1 and 4. Let's go the other way around. Oh, there. How about put it on the right? I had it on the continuity, not diode. Okay. So I was right the first time. Pin 1 is negative. There it is, 0.579. So good. All right. Yeah, and I mentioned in another video that these are all counterfeit. These here are all counterfeit because you can look at the silk screen on this, and you can look at the silk screen on the correct one versus the fake one. And just to show you here, I'll go ahead and read these, and you'll see here's a good one. Pin 1, pin 4. That's a good one. And you can see for comparison, that's a 123. Here's a 130. Same reading, 0.534, 0.577. And now here's the counterfeit one. Doesn't even read a diode. Doesn't even read the diode. No matter what you do. Yeah, see? So these are counterfeit. I haven't put these in a chassis to find out, but so I've got 1, 2, 3 counterfeit ones. And you can always also tell by you're able to alcohol away the silk screen. You shouldn't be able to do that. So there's another. It's been restamped. This is either a fake one or yeah, they're fake. So Anyway, all right, so let's grab this one here that we know is good, and we'll put that in there. So that helps us with that. And here's our HOT. And again, out of circuit, the HOT should have the diode to one leg. I forget if it's collector or emitter, and the other leg should be open. So to the base, we should have, there's our diode, 0.5. This other leg should be open. Oh, I got that backwards. Depends on the part number. I'm not perfect. I don't edit out mistakes, so I don't jump cut mistakes out. I don't care. We're all about learning together here. So I thought it was the K7000 HOT that does that. One of these part numbers of HOTs, I can't recall if it's for the K7400 series, 75, U2000, U5000, or the Polo. I can't think or remember which HOT it is, but one of these part numbers will read like the diode across, one leg, and then of course the base will be continuity, and then the other leg should be open. This one obviously is not, but it's still a good HOT. So as a matter of fact, let me see here. Yeah, I threw the other one away, but it's okay, it'll work. All right, let me bend this so we can get it installed. Should look, actually I think it goes backwards. I'm sorry, it goes backwards this way. But there we go, I got it bent so it should fit in there. But let's do our voltage regulator first. And I turn this around and line the legs up this way so it doesn't give me grief like it's doing now. Okay, there we go. Because these aren't always easy to get in with these B+ wires in the way. Okay, that's in. Let's get one of our screws through, and the other one. All right. And we'll get our HOT installed. And along with our insulator. And these can be invaluable here, these tweezers. You can hold on to the nut and get it started. And you don't want to over tighten this, just to make it snug. There we go. Solder in these new parts. Half of this pad's missing, that's good. So in that case, I'll just bend this over a bit Give it a bit more surface area to hold on to. Alright, that seems okay. Now we'll go to our voltage regulator. Alright, and I'll go through and alcohol all this up later, get all the flux off. There's no reason to really show that. It's kind of self-explanatory. Use a toothbrush and a towel and some alcohol and clean the flux off. So let's get a new fuse installed. Actually, you know what? To save the fuse, I got one of these here. I made this up myself. It's a 2 amp circuit breaker, and it's part number 7277-2-2. It's a 2 amp circuit breaker, and it just runs to a couple of leads here, and we'll use this in place of a fuse in case the system doesn't turn on. We don't blow the fuse. This will pop instead. So I'll have this going for the setup. So but let's give it another look over before we dive too deep into it. Neck board looks okay. Nothing on the neck board would cause the fuse to explode. Our ground does need a little reflow though. That's better. Let's double check our readings. Okay, HOT, good. Voltage regulator, it's reading again, it's 0.15 because we're reading through the B plus pot. If I go to the, B plus resistor, if I go to ohms and test it, you'll see it's 180. There you go, 176. So, yeah. Unless there's something else that's bad, we didn't check that everything that we checked are the main culprits of popping the fuse. So if the fuse still goes, or if the breaker pops, we'll know it's something else. But I'm pretty sure that we've just got it licked. So let's get it on the tube, and we'll fire it up. Yep, I got this. So let's put our stuff away. Oh. Okay. I keep all these on hand just as a reference for which to show the counterfeit versus real one. I need to order some more. Looks like I've only got I got plenty of 123s. I got 2 123s and 1 130, and these 3 are all counterfeit. So I got a couple more here, but I'll have to start replenishing the stock. Oakley dokley. Let me pause here and I'll get this hooked up to the tube and we'll fire it up and cross our fingers. Okay, we're all set back up, ready to go. Reinstalled on the tube. I got anode, neck, yoke, ground, video, and power hooked up. We have our remote board hooked up and ready to go. So we're all ready. We have our circuit breaker ready to go. You can see it on the tabs and it's ready to pop if it needs to. So let's give it some power and see if we get any voltage. I have not turned it on. Let's see what happens. 1, 2, 3. Whoa! There's our problem. Holy shnikes. That Flyback has a hole in it. Holy shnikes. Right there. I didn't even notice that. Wow. Holy shit. Well, looks like we're changing the Flyback too. Alright. Take it back out. Here we go. Alright, let's get this out of here. I actually happen to have a new Flyback on hand. This is the last one that I have. So we'll get this changed out. I'll have to order some more stock. But fortunately I actually had one on hand. So we'll get this installed and we'll get the old one out. Then hopefully we'll be okay. So this one lasted 3.5 years. Not very long in the lifespan of what should be. But who knows? This was before I started buying parts from Peter at Arcade Parts and Repair. Not a single Flyback that I have ever got from Peter at Arcade Parts and Repair has gotten bad on me, has done this. This is probably an eBay purchase or something, because this was before I started buying parts from Peter. So I have more confidence in this one that he's provided than this one. So, yep. Let's get this out of here and see where we're at that point. Well, there went that pad. That's okay, it doesn't go anywhere. Or there's no trace, I mean. I gotta clean this out. There we go. There we go, nice and easy. Alright, take this wire nut off of here. Ideally you'd want to have this soldered, but we're cheating with the wire nut. And then the cap here. Well, there it is. Out with the old. Actually, let's look and see where the arc was. I thought the arc was coming from here, this thing, but that's not where it was coming from. It's coming from right there. There is a huge hole. There's a huge hole right here. So yeah, it was arcing right to the frame on the side through this hole. And yeah, I don't think this is one that's supplied from Peter, because Peter's look like this. 528. It's a different, and yeah, it's different. It's the same part number, but you have -001 versus just 001. So yeah, in the garbage this goes, and we'll get this one in. I dropped that cap. All right, so let's get this installed here. Zoom back out. A little bit too far there. There we go. Okay. Yeah. Normally you'd have to take this screw out and bend this out of the way. But for this instance, I need to adjust this a bit. What happened there? It is. There we go. Okay. Alrighty. First things first is we'll slide this over the focus wire. And again, it's easy to tell these wires. The focus wire is always the fatter. There's normally two wires coming out of the flyback, regardless of whether they're both coming out of the bottom or one's bottom, one's top. The fatter one's almost always going to be the focus, and the skinnier is almost always going to be the G2 wire that hooks to the G2 post on here. So yeah, just general rule of thumb, the fatter wire of the two is always the focus wire, if they're the same color and you're not sure. So we'll go ahead and get that installed on here. Easier said than done. There we go. Alright, that'll work. And then we'll put our cap back on. Okay. And we'll get our G2 wire, and like I said, ideally you'd want to solder these 2 points together, but I'm lazy and I don't care. Alright, that's good. Plug that on. And they all look fairly straight. Oh, come on. Is there a bunch of solder on these that are keeping it from going in? Well, they look okay. There were a couple suspicious ones there. Okay, so what is keeping these from going in then? There we go. Got it. Gotcha. On these giant ground planes, you got to give it time to heat up and flow, or you don't get a good joint. These other ones that aren't on the ground plane are a lot easier to do. And this one here that came off doesn't matter because it doesn't have any pathway. There's no trace. It doesn't have a connection. It's an NC, or no connection, or not connected. So you don't have to worry about that. Like I say, I'll clean all this up off camera, so if you're screaming at the screen, don't worry about it. I'll take care of it. All right. So that completes it. Let's get it hooked up and see what we get. Fingers crossed it works out better than last time, so here we go. Alright, here we go again. We're all set back up. Anode, neck, yoke, ground, video, and power, and remote boards it's hooked up, so that's all 7 items. And we've got our circuit breaker reinstalled, ready to go, just in case. I'm fairly confident that we'll be okay, but yep, new flyback is in. You can see no more, oh hey, I'm popular, I got a message here. No more hole on the top, and no more hole on the side. So let's see what happens this time. 1, 2, 3. Well, hot diggity and shazam. We got high voltage. Ooh, and we got an image. Flyback is usually shipped with the screen pot turned all the way down, but I must have turned it during the installation. So we'll turn our black level all the way down, and contrast all the way down, along with this brightness pot all the way down. And we'll turn up our flyback until we get our raster lines right there. And let's focus it up right there. Flyback down until the raster lines just go away. I'll see right there. Now let's set this up on the tripod. Ooh, something just happened. What just happened there? Something just popped. Very interesting, very interesting. Well, I don't want to turn this back on again, so, well, back to the drawing board. I can't win so far. Let's see what I can figure out now. I don't know what that pop was. You saw it pop, and I don't know if you could hear it, but the high voltage crackled down. So the fuse or the breaker did not pop, so I don't know what happened. Let's try and figure it out now. Actually, I just turned it back on off camera to see what would happen, and it came right on. So I guess we can follow forth here. I don't know. Something popped. I don't know if you can hear it, or if you could hear it. I can't say I heard it, but something popped and I lost my high voltage. But I just turned it back on and it came right back on. Of course, everything is still turned down, so I didn't see an image, but it came back on with high voltage. So let's turn it back on and try to make some adjustments and see if maybe what that pop was, or maybe something I can't say. So let's turn it back on and see if we can make some adjustments and get an image and let it run for a few minutes to see what happens here. So I haven't done anything. I cut away with the intention of taking it apart and looking and seeing if something blew up again. But I wanted to see if it would even turn back on, and it did. So let's see what happens. Okay, it fired right back up. Let's turn our brightness back up. Well, it's still there. it's a bit too wide, but it was set for Killer Instinct. Huh. Well, it's working. I don't know why it popped and shut off, but it fired right back up, and as you can see, it's working. I didn't do anything to it, so assuming it stays running, it looks like we had a blown flyback, a blown HOT, and a blown voltage regulator. And it makes sense that if the flyback was arcing to the frame, it could have very well taken out the cabinet fuse, the 3-amp cabinet fuse. And once I fired it back up with the new fuse, it did not arc inside the machine because I had no voltage regulator, or I had a shorted voltage regulator, so the fuse blew instead of the flyback powering up. Oh, see there? It just popped again. Whoa, huh. I'll have to see if I can't figure out why that's happening. Maybe something is shorting out on the frame? I don't know. The colors are not accurate, but it is working. I wonder what that pop is. God, I can't say I ever come across that before. I'm going to let it run for a while, obviously not on camera, but I'll let it run for a good couple of hours, and if something happens again, obviously I'll detail it or document it, and we'll see if we can't fix it. But if nothing does happen, obviously this will be the end of the video. Maybe it's just settling back in, maybe there's some components that need to settle back in after the flyback was arcing, I can't say, but as you can see, it's working. Voltage regulator, HOT, and flyback. Got it back up and running, and maybe a little reflow too. Well, it's quite interesting. I don't know what the pop is. Well, I'll do the testing here for a couple hours, burn it in, see what we get. But otherwise, yeah, if I come back, we'll do more troubleshooting. If this is the end of the video, then this is the end of the video. Assume nothing else went wrong. Let me do some quick colors, because that's too red. That's better. That's better. What about, I need to focus it here a bit better too. Well, I'd say that's about as good as I can get it. No. Right about there looks pretty good. Yeah, not too bad, not too bad. Okay, well, it seems to have settled down now. Like I say, I'll let it run and we'll see what happens. Thanks for watching. Hopefully you learned something. And like and subscribe if you prefer. Thank you very much.